How's it going, guys? Today I want to go over another interview question on LeetCode. Today we're going to go over a Microsoft question. This is actually Microsoft's #1 most frequently asked question according to LeetCode, and it's called maximum length of a concatenated string with unique characters. Alright guys, so today we're going over another interview question. Again, it's going to be on LeetCode, our favorite. This is a Microsoft question, and this is actually Microsoft's #1 most frequently asked question right now, so it's a really important question to know, especially if you guys have an interview coming up with Microsoft. If you guys haven't already, be sure to subscribe to the channel below and drop a like on this video if you guys appreciate the content that I'm pushing out. To get into our problem today, the problem description says, given an array of strings R, S is a concatenation of a subsequence of R which have unique characters. Return the maximum possible length of S. So basically we're given a list of strings, and all we're asked to do is basically create some combination of those strings such that the characters are unique and return the maximum possible length of that string. So in example 1 here, if we're given these three strings, UN, IQ, and UE, we would output 4. And the reason for that, it tells us, is because all the possible concatenations are the empty string, the string UN, the string IQ, the string UE, the string UNIQ, and the string IQUE. So really we're going to output 4 because UNIQ is one possible result or answer, and all of its characters are unique, right? U does not appear twice, N does not appear twice, I does not appear twice, and Q does not appear twice. Same thing with IQUE, so we output 4 because 4 is the maximum length of a string that we can create that has unique characters. Now in example 2, if we were given these strings here, CHA, R, ACT, and ERS, we'd output 6. And the possible solutions, they tell us, are CHAERS and actors. And again, that's because those are two strings that all have unique characters, and their length is of 6, right? They have a length of 6. So now in example 3, if we were just given one string in which all the characters are unique, we could simply output its length, which in this case here is actually the alphabet, so it'd be 26. Now it tells us that our constraints are what? Well, the array that we're given can only have between 1 and 16 strings inclusive. It tells us also that the length of every single word in our list of words is going to be between 1 and 26 characters. And then it also tells us that every single string in our list is going to only contain lowercase English letters. Okay, so how do we solve this now? So it kind of gives us a little bit of a hint in these explanations, right? It's talking about all possible concatenations, and that's actually a really good hint or indicator for us. So we probably wouldn't actually get that in an interview, but here it's really nice to see this because one thing that we could possibly think about, and really the way we're going to solve this, is we're basically going to take this list of strings, try and generate all unique combinations of those different strings that we have, right? So try taking just the first string, just the second string, just the third string, the first string and the second string, the first string and the third string, so on and so forth, and basically generate all those possible concatenations. And then for every single one of those strings that we can form by combining those strings, we want to check if that string that we have has unique characters. And if it does, we just want to make sure that we're basically keeping track of a maximum so that we can return it from our function. So this is really like a classical DFS. This is like creating all different permutations of these strings. And so we're really going to jump into the code for creating or doing a DFS to try and get this result. So the first thing that we want to do is just have a return variable, right? We need to keep track of the maximum length. So I'm just going to create an integer array called result, and it's only going to hold one thing, and that will be the length of the longest string that we're able to form that has unique characters. And if you guys watch my channel a lot, you guys know that I like to have some sort of shell function and then just write some sort of other magical recursive function that we call that basically gives us the answer. So now that we have this result, we're going to call a recursive function that's going to do our DFS. And then all we actually have to do if we write our recursive function correctly is return whatever's in our result. So for our recursive function, I'm just going to call this max unique. And now we need to pass it certain things, right? The first thing we want to pass it is just the array, so we have access to the strings that we can use. The next thing that we want to pass is actually an index, right? Where we are inside of that array when we're picking different strings. The third thing we want to pass is just whatever the string is that we currently have created, which is going to be an empty string to start. And then finally, we also just need to pass our result to make sure that any single time we find a new answer or a better answer than previously, we can update that variable. So now once that magical recursive function returns, if we do it correctly, all we'll have to do is return whatever is inside of our result. So now to start writing our recursive function, we're going to say public, we're going to say void because, right, this function is really just going to be updating our result variable, so it doesn't need to return anything. And then here we want to call it max unique, and then we're taking a list of strings called R. We're taking an integer that's going to represent the index as to where we are inside of that list of strings. We're taking a string that's going to represent the current string that we've built thus far. And then we're also taking an integer array that's going to hold our result. So now in our recursive function, we always need two different things, right? The first thing that we need is a base case, which is going to tell us when to stop our recursion, right? When our recursion should bottom out, stop, and start returning to the previous recursive calls that called it. So we need our base cases, right? And our base cases are going to tell us when to stop. And the second thing that we need is our recursive calls to make sure that if we're not stopping a recursion, we're actually continuing it. So now for our base case, what do we need? Well, the first thing we need to check is if we go out of bounds of the strings that we actually have access to, right? And so that's going to be whenever our index is equal to the array's length. So if our index is equal to array.size, but we also want something else, right? If we've reached the end of the strings that we have available to pick from, and the current string that we've actually created is better than any previous string we found, we need to make sure we update our result. So I'm going to say not only if we're at the end of our array, but if the unique character count of current is greater than result of 0, then we need to make sure that we update result of 0, right? So I'm going to say result of 0 is really going to be current's length. And so now, I know this seems crazy, but now we need to write this little helper function, right? This is not a built-in function. We don't have this to us available to us in Java. So we need to actually write this function. And again, as you can kind of tell by the name of the method, we're basically going to call it unique character count, and it's going to return the number of unique characters that we have in a string. So again, if we've reached the end of that list and the string that we actually created is a better answer than previously found answers, we need to update our result. So here we're going to say public. It's going to return an integer in terms of how many unique characters that we have, right? And then we're going to say unique character count, and this is going to take a string s. So now we just need to count and make sure that every single character that we have is unique, right? So that's as simple as having an integer array called counts, and that is going to have 26 slots because we're told that all these strings will only contain lowercase English alphabetical characters, so we only need 26 slots to count all of them, right? And now we'll basically just go through every character in s.toChar and now we're just going to try incrementing the counts in each of those different slots, right? So if we say if counts of c minus a, so if c is an a currently, it's going to do a minus a, and it's going to actually increment, right, because we say plus plus here. If we increment that slot and it's greater than 1, right, then, or sorry, if it's actually greater than 0, then we have a problem, right, because we've already seen that number. So we're basically going to count all the occurrences of the current character, right? So if we have an a, it'll be a minus a, and that'll map to the 0th index in our array. If it's a b, it'll be b minus a, and that'll map to the first index in our array. And if any of those counts in those slots are ever greater than 0, that means that we've actually seen and incremented that slot before. So these characters are not unique, so it's not a valid answer. So we just want to return something like -1. But if we actually can get all the way to the end of our function here on line 23, then we know that actually this is a valid candidate for an answer, right? So we just want to return its length because every single character in this string is valid, right? It is valid and is unique, so we're just going to return s.length. So now jumping back to our recursive method, right? This will tell us the base case of when to stop and update our answer. And now we just need another base case that's going to tell us to just strictly stop, right? Stop, and we haven't actually found a better answer currently. So we'll say again, if index is equal to array.size, then we just need to return. And I also forgot, but we want to make sure we put a return statement here so we don't continue our recursion, right? As soon as we find that best answer, we want to update our result and get out of there. So now if we actually have not reached either of these cases, right? If we've not reached the end of the array and found a better answer, or if we've not just reached the end of the array, we need to continue our recursion, and that's where our recursive calls come in. So to actually generate all the different permutations of these strings, we need to simulate taking the string at the index position and adding it to current, and then we also need to simulate not taking the string at the index position and not adding it to current. So that means we're going to have two recursive calls, so max unique, And again, recall it with the current array that we're on. We're going to pass the index that we were on plus 1. We're going to pass current, right? So we're not modifying current, so that means that we're simulating not taking it in this recursive call. And then we're going to pass our results so that we can update it if we need to in that recursive call. And now we're going to do the exact same thing, except the only difference is that we're going to pass current plus whatever thing is at the index position in our array, right? So we're effectively taking current and appending that string at the index position to make sure that we're simulating taking that string. So now hopefully if we've done everything right, this should work. And once we return from this recursive call in line 4, all we'll have to do is return whatever is stored inside our result. So now before we submit this, let's talk about our runtime. So our runtime is we're making one call here, right? So we're making one top level recursive call, but inside that top level recursive call, we're actually going to make 2 different calls every single time for each word. So that's going to be 2 to the n. So 2 recursive calls for every word, where n is the number of words that we're given inside of R. And then in terms of our space complexity, I'd say our space complexity is actually O of n as well. Because we have n words, we're going to go n stack frames deep inside of our recursion. So that will give us O of n space complexity. So again, our runtime is going to be 2 to the n, and our space complexity is going to be O of n. So now let's run this code. Let's make sure that it works. Awesome, and it does. So guys, that's how to solve maximum length of a concatenated string with unique characters in Java. Again, this is Microsoft's #1 most frequently asked question according to LeetCode right now. If you guys enjoyed this video, do me a favor and leave it a like and subscribe to the channel for more. And I'll see you guys in the next one.